A set is a well-defined collection of objects. Some of the most important sets arise in connection with sequences. A sequence is simply a list of objects arranged in a definite order. Remember, a set is a well-defined collection of objects, so a sequence is like a structured set. A sequence or list can be finite or infinite. What we mean by a finite sequence or list is a list that stops after a particular number of steps. Let's call them n steps. An example is given below. It takes 6 steps for that sequence to terminate, so n is 6. A never-ending list is infinite. The 3 dots imply the phrase, and so on. The 3 dots in the finite series is so on to 6, and the 3 dots in the infinite series is so on to infinity. It can sometimes be useful to have compact notation to describe a sequence. Above is an infinite sequence, as the 3 dots represent it continues to infinity. The first term in that sequence is 3. If you add 5, it becomes 8. Add 5 again, 13, and so on and so on. So the pattern is add 5 to the previous term to get the next term. We can create a formula to describe the sequence. Let the first term be called A1. I'm going to call the next term in the sequence AN, and that will be equal to the previous term, which I'm going to call AN minus 1, add 5. It's add 5 because each term in the sequence starting from 3 is adding 5 each time. So 3 plus 5, 8 plus 5, 13 plus 5, and so on and so on. Using the formula, supposing that I didn't know 18 was in the sequence, it's just missing. I know the previous term but, which is 13, and if I add 5 to that, that will be 18, which is the next term in the sequence. So that's how this formula works. It uses the previous term to tell you what the next term will be. This type of formula is known as a recursive formula. Recursive formulas must always have a starting place. In the previous example, that would be A1, which was 3. There's one more type of formula, which I'll explain now. When you have a sequence, the objects in the black box are known as terms, and I'm going to name them that from now on. In the previous example, we used the previous term to define the next term, and that was known as recursive formula. In this example, we're going to use the position of these terms. So this is the first term, second term, third term, so on and so on. If you square the position, first term, you get 1, second, you get 4, third, you get 9, and so on and so on. So there's a relationship or pattern between the position of the term and the term's actual value itself. So let's say I want to know a value of a term. I'm going to call it this symbol here. Let's call the position of the term n. The value of the term would just be n squared. So for example, if I didn't know what that last term was, which is 25, I know its position, which is going to be the 5th term. If I square 5, I get 25. Formulas that use position like this are known as explicit formulas. In the next video, we will cover more examples. If you like this video, consider subscribing and becoming part of my community. It's an immense support and a help for me to continue making these videos. Thank you.